Okay, so now that we've seen what the evidence for plate tectonics is, now we want to talk about what plate tectonics is. And so here is a summary of it, that the Earth's lithosphere, so the topmost layer of the Earth, is broken up into thin plates that are constantly in motion. And the plates can be composed of continental lithosphere, or they can be composed of oceanic lithosphere, or they can be both. And then these plates can be pulled apart, pushed together, or slide past each other, making different kinds of geological features. So here's our lithospheric plates, and there's roughly 12 of them. And you can see that the Pacific plate is a very big plate. Notice that the Pacific plate is completely oceanic. Okay, if you look at the Saudi Arabian plate, you notice it's completely continental. But if you look at the North American plate, you notice it's both continental, North America, and it's oceanic. So it's got both kinds of lithospheric materials in them. All right, so you can find the location of the boundaries between these plates by looking for earthquakes. Earthquakes will map out the location of the boundaries of the plates. Also, you should know the difference between a passive margin and an active margin. So make sure to know those two words, passive and active margins. So an active margin is going to be where plates are colliding. And so you're going to have mountains, volcanoes, and stuff like that. A passive margin is where the plate is moving away from the mid-ocean ridge. And so if you have a continent like this, and then here's the oceanic part of the plate, and here's the continental part of the plate, this part of the plate over here would be passive because it's just being carried away. But over on this side, so let's say that this one is colliding. So let's say this is North America and it's going that way. And then let's say that this is the Pacific plate, and let's say it's going this way, and they're colliding, then this would be an active margin where they're colliding, and then this side over here would be a passive margin. So a active margin here, that's definitely going to be a plate boundary. So the passive one here, notice that this is not going to be a plate boundary because this whole thing is the North American lithospheric plate. All right, so how do they interact? So there's going to be basically three types of interactions for these plates: divergent, convergent, and then transform. So at a divergent plate boundary, the plates are being pulled apart. So what does this do? Okay, it forms new ocean floor at a mid-ocean ridge. So that ridge that goes down the middle of the Atlantic Ocean, that's a mid-ocean ridge. The plates are being pulled apart. Material from the asthenosphere is coming up, and it's hardening, and then it's forming new ocean floor, and then that ocean floor then splits apart, and then new material comes in, and it continues the process. It can also occur under a continent. So this is how a continent is rifted. A continent breaks apart as a result of this process. Okay, you should know the different layers of the ocean floor, so that at depth you're going to have periodotite, and so this is going to be the mineral that is in the asthenosphere. Okay, then as it's coming up to the surface, it's going to start to chemically change, and it's going to become gabbro, which is the crystallized version of basalt. So that at the very, very surface of the ocean floor, you're going to have basalt. Underneath it is going to be gabbro. So gabbro is down here. You got basalt is up here. So this is going to be the lithosphere. And then underneath the lithosphere, down in here, is going to be where that periodotite is. And so this is going to be the raw ingredient that turns into this part here, which is going to be the ocean floor. So as this material comes up, it's going to start to cause cracks. So it's going to start to crack this material, and you're going to have sheeted dikes are going to be in there. And then the whole thing is going to be pulled apart. Now when it bubbles up to the surface, it's going to make pillow basalts, so up here. But then as soon as it hardens, it then breaks apart and it moves off to the side. All right, so just know the different layers to the ocean floor. Okay, another thing is the thickness of the lithosphere increases the further away that you get, and that's because it's cooling off. So when it's very thin when it's first coming up through the crack, but then as it moves further and further away from the mid-ocean ridge, it starts to cool off and becomes gradually thicker. Okay, the next thing that they can do is they can collide, so that the ocean floor can be pulled apart, that's divergence. It can be pushed together, that's convergent. And there are three different ways that the plates can converge, depending on the kind of plates that are colliding. There are two kinds of lithospheric plates. So you have oceanic, and then you have continental. So let's first look at what happens if an ocean plate collides with an ocean plate. Okay, they are both composed of basalt, so they're dense rocks. Dense rocks want to go down. So when two oceanic plates collide, they're both going to want to go down like this. But one of them is going to win. So whichever one is the colder of the two plates, that's the one that is going to be more dense, and so it's going to go underneath it like that. Okay, then as it goes underneath it, so here's this plate, so let's go ahead and put that in. Notice that you've got a trench. So a trench is a major feature formed when an ocean plate collides with an ocean plate. Okay, then the deeper it goes, the hotter it gets, and it begins to melt. And so the lighter parts, the lighter components of this plate are going to melt. They're going to flow back up to the surface, and they're going to come out of volcanoes. So you're going to have a volcanic island arc system as a result of this. So an example of this would be Japan. So you need to be able to find on a picture of the Earth's surface where would be an example of an ocean colliding with an ocean. And an example of that would be the islands of Japan. Okay, the next thing would be what would happen if an ocean was to collide with a continent. So here's your ocean, and now let's say that this is a continent. So this is continental crust, continental lithosphere, oceanic lithosphere over here. They're going to collide. The ocean is always going to go underneath the continent because it's more dense. The continent just basically stays put. So don't have the continent doing this. So that would be incorrect to draw it that way, so that this continent basically stays horizontal, and then this is the one that goes underneath it. But it's going to melt, material comes up, you have volcanic mountains. So this time you're going to have a volcanic mountain system. An example of this would be the Rocky Mountains in the United States. Okay, the third possibility is a continent is going to collide with a continent. So this time we're going to have a continental plate, and it's going to collide with another continental plate. So what's going to happen? They're going to crumple together. So imagine you take two rugs and you move them towards each other, and then they just pile on top of each other. So this is going to make the tallest mountain systems in the world, like the Himalayas. And so that's where India is colliding with Asia, and it's pushing up the Himalayan mountains. Okay, and then another interesting thing about this is why are island arc systems, why do they curve? And that is because we live on a curved Earth. And then when you have something that is going inside the Earth, but it's on, like that finger is pointing into the Earth, you see that it makes a curve around the finger. Just something that's kind of interesting. Another thing about these plates that go inside the Earth, some of them will go all the way to the core mantle boundary. So they go all the way into the Earth, and they pile up at that particular level. But then we've also noticed that some of these plates, they don't go all the way down to the core mantle boundary, and they get stuck at a particular layer inside the Earth. So it's very complicated what the inside of the Earth looks like. Okay, then the last way that these plates can interact with each other is a transform boundary. And so a transform boundary relieves stress. So whenever you got one rock that's trying to go this way and another rock that's trying to go this way, they relieve their stress by breaking. And so that's going to make a fault line. And so you can have, for example, at a mid-ocean ridge, so now this is the top-down view. So here's a mid-ocean ridge, and then because of the curvature of the Earth, sometimes these mid-ocean ridges can be offset from each other. And so here, this plate's trying to go this way, but this plate is trying to go this way. So can you see that stress is going to build up in between right here, so that you're going to have a transform boundary that's going to connect those two. You can also have it where you have a subduction zone. So again, here's a place where they are colliding, but then maybe over here is a plate, over here is a divergent zone. So that over here, this plate is moving this way, and then this one's moving this way. Well, again, you could have stresses that are going to build up here. So there are several different ways of cracking the Earth's surface, but it's basically going to connect either a convergent zone or a divergent zone, or both of them. And so that is illustrated in this picture right here. So you should be able to give me an example of a transform plate boundary on the Earth's surface, and so that obviously would be the San Andreas Fault. Okay, and then you should know what a triple junction is. So that normally, whenever the Earth's surface breaks apart, it tends to break apart into three pieces. And so you can see that's called a triple junction, where you've got three boundaries that are coming together. This is going to be very important when we talk about how do continents break apart, because normally one of those junctions, there's not going to be any movement along that junction, and that's going to be called an allocogen. And so we'll talk about that in a future lesson. Okay, let's take a break, and when we come back, we will talk about what can happen in the middle of a plate.